Okay, for homework 3-7, I'm going to have you watch and write this work down and write the 5 words down. And then at the end, I'm going to tell you about how to complete this assignment. So here we go. These problems, we're going to again review the reading strategy. Because again, you don't want to read all that all at once. That's way too much. So we're going to break it into parts. First part, just read the first little bit. So here we go. It says, I have 2 similar right triangles. So that means they're both same proportions. That means they have a 90-degree angle in them. That's what a right triangle is. Right triangles have a length and a vertical height. Right triangles have angles, little angles, medium angles, and then right angles. But again, right triangles, similar, same proportions. The length, the height, the right angle in this corner, the way you see them. 2 similar right triangles with the same proportions. So again, a little bit at a time. Think about it, a little bit at a time. All right, next, we're going to read a little bit more of this complex problem. So here we go. The first word is I. I. So looking at this problem, it says, I have 2 similar right triangles with a 90-degree angle. The small triangle has a length of 5 and a height of 3. The large triangle has a length of x plus 8 and a height of x plus 2. So again, let's put that in motion here. The small triangle has a length, the bottom piece is 5. A height is 3. So I'm going to put those numbers in. 5 for the length and 3 for the height. So here I go. The next triangle, the big triangle, has a length that's not a number but shown as a little expression here, x plus 8. The other one is shown algebraically as an expression 2x plus 2. So again, the length and the height. Now I want you to read the whole thing again and see what this is asking me for. So it says I have 2 similar right triangles with a 90-degree angle. The small triangle has a length of 5 and a height of 3. The large triangle has a length of x plus 8 and a height of x plus 2. If the triangles are similar with the same proportions, these proportions are all going to be the same, find the length and the height of this big triangle. So I'm going to have to algebraically solve this for x and then plug it back in and find how long each of these pieces is to solve this problem all the way. So for this, since these are similar, I'm going to set this up as an algebraic ratio. I'm going to set up from top to bottom. I'm going to go 3 over 5, and I'm going to stay consistent with my ratio. If I go 3 over 5 with this similar triangle, I'm going to stay consistent and go x plus 2 over x plus 8 with the other triangle. And then once I get that, I'm going to crisscross multiply. 5 times x plus 2, 3 times this x plus 8. It's going to end up being a double distribute problem. The second word is will. Will. So that first part becomes 5 distributed to x plus 2. I put that in parentheses to make sure I multiply 5 by both things there. 3 times this x plus 8. Again, I put that x plus 8 in parentheses so I remember to multiply that 3 by both of those parts. So first thing before I do any inverse operations, distribute. So 5 times x, 5 times 2, 3 times x, 3 times 8 gives me 5x plus 10 equals 3x plus 24. Now I could start my inverse operations. Start on the left, get rid of that 10, minus 10 to both sides. Bring the 5x down, the equal down, the 3x down. 24 minus 10 gives me 14. Stay on that side, the most crucial part. Now I need to start separating the x's over here and keep my 14 on the right. So eliminate that 3x by subtracting 3x on both sides. Bring that 5x minus 3x down, which is 2x. Do that math right there. And then again, finally, my next step, which is something different than adding, subtracting things. I'm going to divide right here because the opposite of multiplying by 2 is dividing. So divide both sides by 2 gives me x equals 7. So I algebraically solve that for x. And then I'm going to take that and plug it in to these two spots right here to find the actual lengths to finish up this problem. So with that x right there, I put that 7 because I know that's what x is now. Plus 8 gives me 15. And then take that same 7, put it up here with this x up here, and add that 2 that's there, and that gives me 9. And again, you can see those are proportional. 3 over 5 is the same proportion as 9 over 15. 15 over 5 is the same proportion as 9 over 3. Again, all those proportions. Going this way, I'm timesing by a scale factor of, let's see, 15 divided by 3. 15 divided by 5 is 3. Timesing by a scale factor of 3 when I'm growing like this, dilating bigger. But of course, when I'm going smaller, I'm multiplying by a scale factor of the reciprocal of 3. I'm multiplying by the scale factor of 1/3. 9 times 1/3 is 3. 15 times 1/3 is 15 divided by 3. 5. Again, know that. All right, next problem. Again, reading strategy. The third word is try. So again, you don't want to look at all that at once. Way too overwhelming. So back to that third word, which was try again. Again, reading strategy a little bit at a time. So I'm going to look at the first little bit and see what we got. All right, here we go. I have two similar right triangles with a 90-degree angle. So let's draw those. So I got one right here. I'm going to draw one that's bigger and similar. Try to make them kind of look the same, but one bigger, one smaller. 90-degree angles. That's what right triangles have. And of course, right triangles, all those angles. So let's see. The next reading, I have two similar triangles with a 90-degree angle. The small angle in the first triangle is shown as 4x plus 2. The same small angle in the second triangle is shown as 2 times x plus 10 in parentheses. So let's see what I got. I got for these triangles, this little angle right here, this little angle, I have two bigger medium angles up here, and I have a right angle. So again, the parts of these right triangles, these small angles, because these are similar triangles, all the angles inside of similar triangles are equal. The lengths of the sides are proportional, but again, remember, inside all of these angles are equal, the corresponding angles. So this little angle and this bigger triangle that's proportional, those angles are equal. This angle up here is equal to that one in the smaller triangle, and of course the two right angles. So I'm showing the small angle in that first triangle as 4x plus 2. The same small angle right here, the same spot in the other triangle, is shown as 2 times x plus 10. And then again, now we want you to start thinking about what kind of questions I'm going to be asking here if I give you that stuff. So it looks like I'm going to be asking you for x, solve for x. Looks like maybe I'm going to have you plug it back in and find these angles possibly. Maybe even more complex, find this angle and then use that to find this other angle up here. And then eventually in math, you'll be able to use these angles in trigonometry to find these lengths. So here we go. I'm going to set this up as these two are equal to each other. So 4x plus 2. All right. Again, overstep. I should read it again. Here we go. I have two similar right triangles, 90-degree angle. The small angle in the first triangle as shown as 4x plus 2. The same small angle in the second triangle is shown as 2 times x plus 10. Solve algebraically, and looks like I misspelled that. Solve algebraically for x. So it looks like I'm solving that for x, finding out what x is. And then find how many degrees the small angle is. So it looks like that's what I'm indeed doing. I'm solving for x. And then I'm going to use that to plug in and find that angle in degrees. So here I go. 4x plus 2 equal to 2 times x plus 10 in parentheses. So because those angles are equal, 4x plus 2 equal 2 and then parentheses x plus 10. First part does not need to be distributed. The second part, distribute 2 times x. 2 times 10 gives me 4x plus 2 equals 2x plus 20 when I distribute. Get rid of the number on the left side, minus 2 minus 2. The fourth word is my. So again, I'm going to take away that 2, bring down the 4x, the equal, the 2x. This gives me 18. Stay on this side, eliminate the 2x, minus 2x, minus 2x. 4x minus 2x gives me 2x. Bring down the equal, bring down the 18. And then my last step, of course, is another step finally different than adding, subtracting terms. I divide both sides by 2. And that gives me x equals 9. So that is solved algebraically. That's my answer for x. And I'm going to use this to plug it into either one of these. I'm going to show you both. So if I take that 9 and plug it right here where that x used to be, it gives me 4, and then that 9 right there, plus that 2, gives me 36 plus 2. And when I add that up, that gives me 38 degrees. And of course, that plus 90 taken away from 180 will give me that last one. This one right here, 2, put that x where 9 where that x is right there. And that gives me 2 times 19, which is again is 38. And of course, I could have got that by distributing. 2 times 9 is 18. Make sure, of course, you distribute. Don't write 10 right there. That's really 20 if you're distributing. And of course, 18 plus 20 gives you 38 degrees too. All right, the last word is best. Best. Okay, what we're going to be doing, I'm going to be on your Google Slides pasting a problem for you to do. And then when you do this and you get it correct, I'm going to send you another one. I want to see who could get through, again, 5 levels. I'm going to go 5 separate levels. The first one to get through all 5, I'm going to guarantee you $1. I'm going to pay you. You're a professional. But again, look on your Google Slides. I'm going to paste a problem on here for you to do. I would like you to write the 5 words from the video you just saw to prove to me that you watched it, and then do the problem, and then I'll send you back feedback, and if you're correct, I'll send you another one. And if you get through 5 levels, full credit, and of course the first one that does it, I'll give you $1. So good luck. I will see you again on Tuesday. Good luck, good luck.